right? Here, reactants here, products here, activated complex. So they have given the details of a reaction like this. And if they ask to draw the energy profile, Shakti Pathikada, potential energy, right? With the reaction progress. Oh, Arayana. Come on, come on. Right? If they ask to do like that way, now when you are writing the reactants and products, they have given the reaction, say 2P plus Q, right, into R. You have to write this with the coefficients. Coefficients ekkaliyanno. The other thing, if physical states given, you have to write the physical states also. Because it's an energy profile. Energy profile in the components. Reactants products if given like this way and also draw it. 2P gas, Q gas, R gas. With that you have to draw it. හරිද? විභාග ප්‍රශ්න කරනකොට හම්බෙයි. ලොකු ලකුණු ගොඩක්. නමුත් coefficients ලියලා නැත්නම් ලකුණු නැහැ. Physical states නැත්නම් ලකුණු නැහැ. තේරුණාද? All right. Below this, right? In an elementary reaction, it is not possible to identify intermediates. In an elementary reaction, it is not possible to identify intermediates. Identify intermediates. Full stop. Only reactants and products. Only reactants and products are possible in the reaction. Are possible in the reaction medium. Only reactants and products are possible in the reaction medium. Asterisk mark and write this. Activated complex within a bracket transition state, close bracket, is a highly unstable state. Highly unstable state, comma, which immediately pass into the products, open a bracket and write, or sometimes again to the reactants, which immediately pass into the products. Within a bracket, or sometimes again into the reactants. Hence, it is not possible to observe the activated complex. Not possible to observe the activated complex in the reaction medium. Not possible to observe the activated complex in the reaction medium. Subtopic. molecularity. Molecularity. Molecularity of a reaction. Molecularity of a reaction. Right? Molecularity of a reaction, actually we define this one by concerning an element reaction. मैं और देतो कहाँ लाते पुनः define करा. We define this one for a element reaction. For the multi-step reactions also we can take it with a condition. So what is mean by the molecularity? The exact definition like this way. Say the element reaction A plus 2B into C, for example. Okay. Molecularity mean minimum number of reactant molecules need to complete this reaction. You want to happen this reaction, minimum number of reactant molecules need. We call that one the molecularity. හරිද? Real definition එක ඕක. ඒ කිව්වේ මොකක්ද? A with 2B. Now this is an elementary reaction, right? One A molecule, B molecule, they are whether the reaction possible to happen? No. A molecule එකක් තියෙනවා, B molecule එකක් තියෙනවා. reaction එකට වෙන්න පුළුවන්ද? පුතේ මේක දැන් elementary reaction එකක් නේ. එහෙනම් මේ reaction එකේ step එකක් කියන්නේ A with 2B produce C. එතකොට B එක්කෙනයි A එක්කෙනයි හිටියා කියලා A B join වෙලා product එක දෙන්න බෑ. No way to give the product there. Minimum number of molecules required there is 1 of A and 2 of B. A එක්කෙනෙකුයි B දෙන්නෙකුයි හිටියොත් ඔන්න C එක්කෙනෙක් හදන්න පුළුවන්. Can produce 1C. Reaction possible to initiate. You know way to happen the reaction. මවුල වලින් නෙමෙයි මම මේ කියන්නේ molecules. හරිද? So one molecule of this one and if two molecules of this one, reaction possible to initiate. A minimum number of reactant molecules required to happen the reaction. Okay, in an elementary reaction, minimum number of reactant molecules required to happen the reaction. Call that one as the molecularity. So here one of this one, two of this one. For the overall reaction, we say the molecularity is 3. One of this one, molecule with respect to this one is 1. Here 2. Okay. So molecularity is the minimum number of reactant molecules required to happen the reaction. But when you have the balanced reaction, stoichiometric coefficients directly give that idea. If the reaction is elementary, stoichiometric coefficients mean directly they are the molecularity. But if a multi-step reaction, in a multi-step reaction, number of steps there are, number of steps. Then at once you can't decide the molecularity. Right? In a multi-step reaction, number of steps. I told you number of elementary steps. For each of the elementary step, you can think about the molecularity. Overall reaction for that one, you cannot think about the molecularity. Overall reaction එකට නෙමෙයි මේක define කරන්නේ. හරිද? හා. මේක තේරුණානේ? ලියන්න. Molecularity of a reaction. Minimum number of molecules, minimum number of molecules, comma, atoms comma, atoms or ions. Atoms or ions of the reactants. Molecules, atoms or ions of the reactants required for the reaction to occur. Required for the reaction to occur. Is known as the molecularity of an elementary reaction. Molecularity of an elementary reaction. ඔගොල්ලෝ topic එකේ ලියන්න මේ පුතේ molecularity of a reaction within a bracket right there elementary reaction. Molecularity of a reaction within a bracket elementary reaction. Continue the sentence earlier one. Molecularity of a reaction, full stop and right. This is equal to the sum addition, sum of the equal to the sum of the stoichiometric coefficients of the reactants. Sum of the stoichiometric coefficients of the reactants in the balanced chemical equation. Next line. With respect to the molecularity, elementary reactions can be classified as given below. Break එකක් අරන් එන්න. Right. Classified as given below. Stop there. Prepare 2-column table. Columns දෙක table එකක් ගන්න. Reaction and the molecularity. Reaction. We need a wide column here. Molecularity, just a figure here. Molecularity. First example. PCl5 into PCl3 and Cl2. right? So molecularity is 1 here. These are elementary reactions. Elementary reactions, right? One step reactions. Elementary reactions. So here, right, coefficient, stoichiometric coefficient directly give the right molecularity. So molecularity 1. We call that one as the unimolecular reaction. Unimolecular reaction, right? Unimolecular. So mark that one as unimolecular. Then another one, 2Hi into hydrogen and iodine. Here, two molecules need to happen the reaction. At least there must be two molecules. මේ කියන එක තේරෙනව නේද පුතේ? දැන් හිතන්නකෝ if only one HI molecule. Moles වලින් හිතන්න එපා. If only one HI molecule, now we have the H2 and I2. ඒතර එන්නේ නම් hydrogen H and I. එක molecule එකක් තිබුණොත් reaction එක වෙන්න බෑනේ. At least there must be two molecules. Then H2 and I2. තේරෙනවද කියන දේ? හා. So 2 here. Bimolecular reaction. Molecularity 2, bimolecular. Then NO plus O3. NO plus O3. NO2, right, and O2. Again this one, molecularity 2. Again a bimolecular one. Bimolecular. As the next one, take SO2 plus O2. 2SO2 plus O2. 2SO3. Molecularity 3. Trimolecular. Right? Trimolecular, you correct that one to termolecular. Given one. Make a venas karagana. Molecular. Termolecular. Another one example. A termolecular one. Carbon dioxide, oxygen. Carbon monoxide, oxygen. 2 carbon monoxide plus oxygen. 2 carbon dioxide. Again termolecular. Termolecular. Right? So whether the molecularity, whether it is possible to have 0? No. Fractions? No. Right, Liagan. Below the table. Molecularity is a theoretical concept. Molecularity is a theoretical concept. It cannot be zero, comma negative, comma fractional, comma, infinite and imaginary. Infinite and imaginary. Right? Now earlier we had the topic molecularity of a reaction, element reaction, right? Next later I will discuss about the multi-step reactions. In that place again I will give this idea, but here, right, relate to the multi-step reactions also. Want to give a statement here. මේක දැනට ලියලා තියාගන්න ඉගෙන ගත්තට පස්සේ තේරෙයි ආ. Molecularity of a asterisk mark එකක් දාලා ලියන්න. Molecularity of a multi-step reaction is defined as the molecularity of a multi-step reaction is defined as the minimum number of reactant particles, minimum number of reactant particles within a bracket, molecules, atoms or ions, within a bracket, molecules, atoms or ions, close bracket, involved in the rate determining step. Involved in the rate determining step. Rate determining step. වේග නිර්ණ පියවර. පටන් ගත්තේ අපි is defined as කියලා නේද? බලන්න. එහෙමද ලිව්වේ? in the rate determining step. Right? මේක underline කරන්න. That statement take into a bracket. Right? ඒ මුළු එකටම bracket එකක් දාන්න. හේතුව තාම අපි ඉන්නේ elementary reactions වල. Still you are learning the elementary reactions, but molecularity definition we can give that one in two ways. අහන්නකො පුතේ. We can give that one in two ways. Two ways I mean if a elementary reaction directly we can see number of molecules or the particles, right? Minimum number of particles, right? That should involve in the reaction. That is the right molecularity. That is for the elementary reaction. Okay. If a multi-step reaction happen in number of elementary steps. Pure ගණනාවකින් වෙන්නේ. In that one, we identify a step. We call that one as a rate determining step. Right? If you have say number of steps in that one will be rate determining step. Right? In a multi-step reaction, we define the molecularity using this one. මේකෙන් තමයි define කරන්නේ. ඇයි ඒ කියන එක පස්සේ තේරෙනවා ඔයගොල්ලන්ට. හරිද? එතකොට දැන් මේ අවුරුද්දේ කාලා තිබ්බ define කරන්න. The definition එක ක්‍රම දෙකකට ලිය හැකියි. Number of particles involved in the rate determining step. That is for a multi-step reaction. Number of particles involved in the elementary step. That is for a one-step reaction. තේරුණාද? මං මේ definition එකත් මෙතනට අරන් දුන්නේ ඔයගොල්ලන්ට අර right molecularity definition එකක් ඇහුවොත් එහෙම දෙකම එකට ගන්නකොට. Right? In a elementary reaction directly, right, you can write that one, but if a multi-step reaction, using the rate determining step. Right? The multi-step reaction එක හිතන්නකෝ SO2 O2 SO3. This one happen in number of steps. So molecularity mean 2 plus 1 3. No, not that one. Make a multi-step reaction එකක් නම් this is the overall reaction. This is the overall reaction. This one happen in number of steps. Then molecularity equal 3. You can't say like that. තේරුණාද? එතකොට ඒක ඇතුලේ තියෙනවා in that one we have number of steps like this way. In that one we identify one step like this. In that one how much of particles involved. That is the definition. තව විදිහකට කිව්වොත් molecularity we define for an elementary step. ඒක ඉපේක තේරුණාද? molecularity එක define කරන්නේ elementary reaction එකකට. Elementary reactions එකයි නම් if only one elementary reaction that is directly a one step reaction or a elementary reaction. Multi-step reaction mean number of elementary steps. Elementary steps ගොඩක් තියෙනවා. ඒතර ඒක එක්කෙනෙක් අරගෙන තමයි මේ කියන්නේ. ඒක define කරන්නේ rate determining step එකකින්. මේක තාම තේරෙන්නේ නැහැ. ප්‍රශ්නයක් නැහැ. මට ඕන කරේ එක තැනකට දෙකම ගේන්න definitions හා. ඔහොම තියන්න ඕක. කලින් කියපු ටික තේරුණා නම් ඇති. ඒ ටික තේරුනේ නැද්ද? හරි. ආපහු එන්න සාමාන්‍ය නෝට් එකට ලියන්න. දැන් ඔක බ්‍රැකට් එක දාන්න කිව්වේ. When consider an elementary reaction, molecularity directly represent the order within a bracket overall order of the reaction within a bracket overall order close bracket of the reaction. Therefore stoichiometric coefficients are the orders. Stoichiometric coefficients are the orders with respect to each component. Are the orders with respect to each component. Examples. A plus 2B right. මේක ලියන්න කලින් ඔයගොල්ලෝ දැන් ලියපු sentence එකේ තියෙන පුතේ when consider an elementary reaction molecular directly represent the order. red pen එකකින් ඒක අන්ලයින් කරන්න ඉස්සෙල්ලාම. Elementary reaction mean molecularity directly known. Molecularly known mean orders known. කෙලින්ම orders විදිහට ගන්න පුළුවන්. හරි? Now write this one A plus 2B into Z. Molecularity equal 3. 1 here, 2 here. Therefore it is 3. හරිද? Then below this right. If above is an elementary reaction, Above is an element reaction. Overall order of the reaction is 3. Overall order of the reaction is 3. Next line. Rate low is directly given as. Rate low is directly given as. Rate equal K A concentration B concentration squared. හරිද? පැහැදිලිද? Somewhere they are given. හරියට දෙනවා ප්‍රශ්නවල, right? Following is an elementary reaction. Like that, and they will give the reaction. And they will ask the question. So, right, when they are asking the question, first of all, we have to think about the rate low there. Elementary reaction mean directly stoichiometric coefficients are the right molecularities. So molecularity we consider 2 plus 1 like that is 3. Then stoichiometric coefficients directly they are the orders. තේරුණාද? තව ඉදිරියට මට ඕන වෙනවා මම මෙහෙම එකක් ලියනවා හිතන්න පුතේ A plus B plus C A plus B plus C into D. Rate law for the above reaction is rate equal K A concentration B concentration. Reaction given like this way. And they have given the rate like this way. Rate equation. Rate law. මොනවද ඔයගොල්ලන්ට predict කරන්න පුළුවන්? I told you this reaction given. මම මොකද ඒ ගැන කිව්වේ නෑ. Reaction given, rate law given like this way. What you can predict? මොකක්ද කියන්න පුළුවන්? In this one, the concentration of C is not included. Concentration of C is not included. If this one is an elementary reaction, what happens? Element reaction mean 1 here, 1 here, 1 here. Any component cannot miss there. Component එකක් miss වෙන්න පුළුවන්ද එතනින්? බෑ. But here one component is missing. එක්කෙනෙක් නෑ එතන. Mean this one is not a elementary reaction. මේ decisions හරි වැදගත් පුතේ ඈ. මම ඉදිරියට තව ගන්නවා ඊට කලින් කිව්වේ මේ. මේ ටිකේ ඉඳලා යන හින්දා. They have given a rate law. In that rate law, some components not there. Mean directly you can decide this is definitely a multi-step reaction. This is not an elementary reaction. තේරුණාද කීප එක? This is a multi-step reaction. හරි නේද? හැමෝම this is all right. Another example. Below this one, right? Earlier PCl5 reaction, write that one. PCl5 into PCl3 and chlorine. PCl5 into PCl3 and chlorine. In front of that one, right? Molecularity 1. PCl5. PCl3. Chlorine. Molecularity 1. Right, with that molecularity 1, you can write the rate law, the rate equation, rate equal K PCl5. Here I haven't given the physical states, right? Later with the physical states, you can take it. මෙතන මම මේ අදහස් විතරයි ගත්තේ physical states දීලා තියෙනකොට ලියන්න ඕන. Even in the rate law here. මේකත් ගන්න 2HI Complete that one also. Take SO2O2 reaction. SO3. Complete that one also. Here the molecularity 2, rate equal K HI concentration squared. Here the molecularity 2 plus 1 like that way. 3, rate equal K SO2 squared O2. Like that. Haride? Now those things all right. If they have given an elementary reaction, now you know the details. If they have given an elementary reaction, directly we can write the rate law. Right? If rate law given in that one, if some terms missing, it cannot be an elementary reaction. Because elementary reaction in that one, at least the molecularity should be 1. අදුම ගානේ එකවත් වෙන්න ඕන. බිඳුව වෙන්න බෑ. Cannot be 0, cannot be fractions like that way. Earlier you learned that. තේරුණාද? පොතේ මේවා පාඩම් කරනකොට පොඩ්ඩක් ඒ කියන්නේ පොඩි සංයමයක් එක්ක නීට් එකට පාඩම් කරන්න ඕනේ. නැත්නම් පටලැවෙනවා. තේරුණාද? Now we'll pass the multi step. දැන් ඔන්න අපි ඊළඟ තැනට යනවා. Multi step reactions. Multi step reactions. I told you multi-step reactions. Most of the reactions are multi-step reactions. Even we feel that one as a simple process, hydrogen plus oxygen, water, or nitrogen, ammonia, we feel it's a simple reaction like that, but it happens in number of steps. Most of the chemical reactions, even when the reactions are very simple, taken place in a series of simple steps. Taken place in a series of simple steps. Within a bracket, elementary steps. Elementary steps. So when you consider a multi-step reaction in that one, first step, produce the intermediate, second step, third step, like that way. If you take the collection of that one, the overall reaction, we can see the overall reaction, but it happens in number of steps. Each of that simple step, we can say that one as an elementary reaction, another elementary reaction, another elementary reaction. That means multi-step reaction mean, right, number of elementary steps together. Single step reaction mean only one elementary reaction, elementary step. Elementary steps එකයි නම් අපි කියනවා single reaction, single step. Or in another way, elementary reaction. If number of elementary reactions, right, that is a multi-step reaction. හරිද? දැන් මේ මෙතන පුතේ A plus B into C, C plus B into D, net reaction E plus 2B into D. This is overall reaction. That one happened in 2 steps. A plus B into C. C is the intermediate. C. Produce here, that one involve the reaction in the next step. Intermediate. Overall reaction is this one. Just by observing the overall reaction, we cannot decide the orders. Making orders can't be. Reason is this one is a elementary step, this one is a elementary step. Because this one is a elementary step, right? For this one, I can write. See, here I will take that one as R1, R2. Overreaction rate, I will take that one as R. R1, rate 1. I can write K dash A concentration, B concentration. Because this one is a elementary reaction, for that one I can write the rate law. එයාට මට rate law එක ලියන්න පුළුවන්. තේරුණාද? This one R2 K double dash, a different constant here, right? C concentration, B concentration. හරිද? Then overall reaction R, rate R, K, this is real rate constant, right? A concentration, B concentration, this one not known, this one not known. Why they are not known? Because we don't know in the mechanism how these rates affect to the overall rate. මේ overall rate එක නෙමෙයි. අපි දකින්නේ මෙයා විතරයි පුතේ. දැන් mechanism එක දීලා නැත්තම්. If mechanism not given, we have this reaction only. Then how to write the rate law for this one? Rate equal, like that way. No way to write it. But if you know the mechanism එක දන්නවා නම්, for this step like that, I can think about rates. තේරුණාද? After taking the rate laws or the rate equations like this way, if you know the effect of this one, how this rate affected the overall rate, how this rate affected the overall rate, ඒකත් දන්නවා නම්, if that one also known, we can produce this one. මේ multi step reaction එකේ මේ තියෙන elementary steps. එහෙනම් මට මේ ඕනම elementary step එකකට, for any of these elementary step I can write the rate law. Right? But R1, R2, how that one involved to this capital R overall rate, we don't know that one. හරිද? තව පොඩ්ඩකින් මම ඒකත් කියලා දෙනවා. How these involve. After deciding how these involved is the overall rate, when you have the mechanism like this, you can write the rate law. Effect එක දන්නවා නම් අපිට පුළුවන් මොකද්ද? rate law එක ලියන්න. දැන් ටික ටික තහවුරු වෙන්න ඕනේ. elementary reaction එකක් නම් පුතේ කිසි ගැටලුවක් නැහැ, එයාට ලිව්වා. දැන් overall rate එක ඇතුලේ, sorry, multi step reaction එකක් ඇතුලේ තියෙනවා elementary reactions ගොඩක්. දෙකක් තුනක් තියෙන්න පුළුවන්. එතකොට ඒ හැම කෙනාටම වෙන වෙනම ලියන්න පුළුවන්. Separately we can think. But how those rates affect the overall rate, we don't know that one. Therefore, we can't produce the rate law for the overall reaction. But mechanism given and effect of this rate to this one given. mechanism එකක් දීලා මේගොල්ලන්ගේ බලපෑම මෙයාට කොහොමද කියන එක කියලා තියෙනවා. ආන්න එතකොට අපිට පුළුවන් rate law එක produce කරන්න. හරිද? දැන් අපි එන්නේ යන්නේ එතන. right? දැන් ඔය ටික හරිද? එතකොට මෙතන මතක තියාගන්න ඕනම තැනක elementary reaction එකක් තියෙනවා, elementary step එකක් තියෙනවා. ඒ step එකට අපිට rate equation එකක් ලියන්න පුළුවන්. rate law ලියයි. තේරුණාද? Write this. Known as multi-step reaction. එතන නේද අපි නැවතුවේ? හා. Example. Example. මේක ලියන්න. O3 gas into O2 gas and O gas. First step. This is step 1. Then O3 gas plus O gas. O3 gas plus O gas. 2 O2 gas. Step 2. Second step. Take the addition of these two. O gas cancel. Right. With that you can have 2O3 gas pass into 2O2 gas plus 3O2 gas. 2O3 gas into 3O2 gas. This is the overall reaction. එකත් ලියන්න. Overall reaction. Overall reaction. Next, right. It is possible to illustrate a multi-step reaction. Possible to illustrate a multi-step reaction by an energy profile. By an energy profile as given below. As given below. One plots the Akana one. One is exothermic one, the other one endothermic. Exothermic one and endothermic one, right? What the decade better the No. Not exothermic endothermic. Steps දෙක මාරු කරනවා. මේ බලන්න. එක ළඟ ගන්නකො plots දෙකක්. Reaction coordinate. Reaction coordinate. Potential energy. Here also energy. In one, I will take the first step is a easy one. Second one is a difficult one. මං මාරු කරනවා පියවර දෙක මෙහෙම. Reactants. Small energy barrier and a large energy barrier. And come to the products. reactants. First, this one produce intermediate here. And now come this barrier and come to the products. Harida. In that one, Harida. In that one, this is the intermediate. Mark Ranapati. Intermediate. I කියලා ලකුණු කරමු අපි. Separately mark that one as intermediate. Intermediate. This place activated complex, so I will mark that one as TS1. TS1 mean transition state. Transition state 1. First transition state. TS1. Right? Then this one, TS2. Transition state 2. Collision theory के මතකයි නේද ඉගෙන ගත්තෝ. Transition state. You learn how to draw that one. Breaking bonds, forming bonds like that. Right? This is second transition state. Now, when taking place this reaction, formation of intermediate happen easily. Intermediate එක පහසුවෙන් හැදෙනවා. But intermediate to the product, that step is difficult. දෙවෙනි step එක අමාරුයි. තේරුණාද මං කියපු එක? First step happen easily. Second step is difficult. Right? For the overall reaction activation energy, වැඩ ඉවර කරලා අහන්නකො පුතේ මේක. තාම ලියනවද? ඉක්මනින් ලියා ගන්නකො. Then බලන්න මේ. If I consider reactants into intermediate, activation energy varies this much. මෙන්න මෙච්චරයි. හරිද? මම අන්තිම ස්ටෙප් එකේදී ඔයගොල්ලන්ට ආපුවම මේක අඳවනවා. Right? Up to this place, that is reactants into intermediate, activation energy barrier. Reactants into products, highest energy barrier from this place up to this place. Then in overall reaction, activation energy barrier is this one. In the overall reaction. තේරුණාද? මේක ඕකම් වුණාට වැඩක් නැහැ. බලන් ඉන්න වෙනවා මෙයාට. මේක පැන ගන්නවා. For the overall reaction, activation energy barrier. For the first step, activation energy barrier. For the second step, activation energy barrier. මේ ඉන්න තැන ඉඳලා කොච්චරක් උඩට යන්න ඕනද? Intermediate from that one up to this place. තේරුණාද? එතකොට මේ step එකේ this step happen easily, but this step is difficult. මේක තමයි අමාරු පියවර. දැන් එහෙම මතක තියාගන්නකෝ. This step happen easily, but this step is difficult. Activation energy barrier high in a step mean that step is difficult to happen. barrier එක විශාලෙන්න ඒ පියවර සිද්ධ වෙන්න අමාරුයි. තේරුණාද? මෙතනට එන්න. Again, reactants. First barrier is large, second one is a small one. And come to the products. තොරතුරු ටික එහෙම මාක් කරන්න. Intermediate here. This is TS1. This is TS2. TS2. මේ ටික ලියලා තියාගන්න පුතේ. TS1 TS2. I mean intermediate. TS1 mean transition state 1. TS2 mean transition state 2. First transition state, second transition state. Right? Now, when you consider this reaction, මං steps දෙක මාරු කරා. Here, difficult to happen this step. Here, difficult step happen the first step. දැන් ඔයගොල්ලන්ම තියෙනවනේ දෙයක් මෙතන. If this one overcome, it will easily pass to the products. නේද? This energy gain mean no matter about this one. Reaction pass to the products. But here this one reach to the intermediate. But have to wait there. එයාට ඉන්න වෙනවා මෙතන. Intermediate එක produce වෙලා මේ හරියට යනවා intermediate එකට එනවා. මේ රේට යනවා intermediate එකෙන් ආපහු reactance වලටම එනවා. කොහොමම ඉන්න ගමන් තමයි can overcome this one. හරිද? ඔතනින්ම කියලා දානවා කියලා බැලුවේ. තව ටිකක් යන් කොහොම? මේ ටික ලියන් යමුකෝ අපි. පාලි ලියන්න පුතේ. Following things are important. Following things are important in multi-step reactions. Following things are important in multi-step reactions. Points are Liana. Number one, overall reaction is the sum, SVM, sum, addition, sum of elementary reaction steps, sum of the elementary reaction steps. Second point. A species that is formed. Second point. A species that is formed in one step. Formed in one step and used up in a later step. Is an intermediate. Avudeliana is an intermediate. Third point. A species that is used in one step Species that is used in one step. Comma. Increase the rate of the reaction. Increase the rate of reaction. Rate of the reaction, comma. Regenerated in a later step. Regenerated in a later step. Regenerated in a later step is called a catalyst. Is called a catalyst. හරිද? ඔය පාඩමේ පුතේ අවසානටම ගිහිල්ලා ආපහු මුලින් ඉඳන් බලාගෙන ඉන්න ඕනේ. ඒතකොට තමයි හොඳට තේරෙන්නේ පාඩම. හරිද? මොකද එකකට එකක් සම්බන්ධයි. මුලදී කියපු සමහර දේවල් 100%ක් තහවුරු වෙන්නේ අය තොරතුරු ටික දැනගෙන කියවනකොට. right? Next point. හතරවෙනි කාරණේ නේද? Neither intermediates no NOR no neither intermediates no NOR catalysts, neither intermediates no catalysts are seen in the overall reaction, and the overall rate low. හරිද? overall reaction එකේ අපිට intermediate සුත් නැහැ, catalyst එකක් නැහැ. overall rate low එකේ intermediate සුත් නැහැ, catalyst සුත් නැහැ. හරි? රුලක් කරලා ලියන්න. When proceeding a multi-step reaction, it is possible to assume the reaction rates of බහුවර්ණ පේපර් එක දාන්න. නැති වුණොත් පොතෙන් හරි ගන්න කියන්නේ. Assume the rates of each elementary step as given below. ලියන්න පුතේ මේක. A plus B into AB I'll take this one as R1. A plus B into AB. Take this one as the step 1. Step 1. AB plus B. AB plus B. AB2. Step 2. Rate of that one R2. A plus 2B. AB cancel there. We did A plus 2B. A plus 2B. AB2. Rate R. Overall reaction. Overall reaction. Here the R1. K1 or K dash. We'll take K1. R1, K1. A concentration, B concentration. Coefficients 1, 1. මෙතන එකයි තියෙන්නේ. That is why I use orders 1, 1. හරිද? Because it is an elementary step. Because it is an elementary step. Then R2. K2. AB concentration. B concentration. AB concentration, B concentration. Right? Then net reaction is here. Net reaction. In that one, rate low, you write here R equal K. A concentration. Right? B concentration. Simple A, simple B. But simple A, simple B, we don't know that one. These orders, we don't know that one. කලින් කියලා දුන්නු ටික. හරි? ලියන්න. According to above, තේරුම් අරන් නේද ලියන්නේ? මේක පුතේ එලිමන්ට් ස්ටෙප් එකක්. එහෙනම් coefficients වලින් ලිය හැකි rate law එක. This one is a element step. Therefore, using coefficients, we can write it. Overall reaction is this one in that one. Right. So for this one, we want to think about the reaction rate. Rate equal K. That is why earlier we learned these are experimental values. By doing a practical, experimentally you have determined this one and this one. But somewhere if you know the mechanism එක විතරක් දැනගෙන බෑ. And how these rates affect the overall rate. ආන් ඒ කාරණා දෙකම දන්න ඕන. Then you can think about the overall rate. ලියන්න. According to above, multi-step reaction. According to above, multi-step reaction. At once, it is not possible to predict. At once, it is not possible to predict the order of the overall reaction. Not possible to predict the order of the overall reaction. Order of the overall reaction with respect to each component. With respect to each component. Comma. Because we don't know the contribution of rates Because we don't know the contribution of rates of elementary reactions. Contribution of rates of elementary reactions to the overall rate. Therefore, usually we conduct experiments to decide the orders of the overall reaction. To decide the orders of the overall reaction. Right. Next topic. ඊළඟ දවසට ටිකක් ඉතුරු වෙනවා. දැන් මම අද හිතන් හිටියේ මේ ටික ඉවර කරලා ඉලෙක්ට්‍රෝකෙමිස්ට්‍රි පටන් ගන්න. හරි. යන්න බෑ ඉච්චර වේගෙන්. ඕගොල්ලන්ට තීරුම් කරලා දීලා යන්න ඉපේ. Then reaction mechanisms and the rate law. Reaction mechanisms and the rate law. Reaction mechanisms and rate law. As told earlier, right? Earlier we had first step, second step, and the overall reaction. I told you, if you want to think about the rate law, we can write the rate law using the mechanism. Possible. Mechanism එක දානවා නම් rate law එක ලිය හැකියි. But we need two things. We need the mechanism, one thing, right? And also we need the contribution of each elementary step to the overall rate. Overall rate එකට එක එක elementary step එකේ contribution එක ඕන. ඒ දෙකම දන්නවා නම් if you know the both, you can write the rate law for the reaction. හරිද? ලියන් ඉන්නේ ටික. When the reaction mechanism is known, and the contribution of rates of elementary steps, for the overall reaction is known. For the overall reaction is known. It is possible to write the rate law for the overall reaction. It is possible to write the rate law for the overall reaction. Underline කරන්න පුතේ. Mechanism known. Contribution of rates to overall reaction known. contribution of rates to the overall reaction known. Topic clear na subtopic rate determining step RDS. Rate determining step RDS. මේ බලන්න පුතේ. කියව reaction කලින් අපි mechanism එක ගමුකෝ A plus B AB AB plus B AB2 overall reaction A plus 2B AB2. Say for example A plus B into AB. ඉතා හොඳින් ආගන්න මේ ටික. Say this one happened very rapidly. පළවෙනි පේර ඉතාම වෙගෙන් වුණා. Within 2 seconds. Within 2 seconds complete the reaction. AB with B AB2. That one taken place, say it is around 5 minutes. Right? Now to complete the reaction, 5 minutes, 2 seconds taken, like that way. It is like almost 5 minutes taken to complete the reaction. Minute to pahai tappara dekai. 16 to 5. 300. Right? 302. Consuming 302 seconds to complete the reaction. In another way, complete the reaction to that one take 300 seconds. කිව්වත් නිකන් එක ළඟ වගේ නේද? එකම නෙමෙයි. Right? But right, like that this one is a rapid one. This one is a slow one. Overall reaction, how much of time take to complete the reaction? 302 seconds. That one decide by which step from these two? This one. Right? The slowest step in our multi-step reaction. Slowest step. මේක පුතේ දැන් තප්පර දෙකයි කිව්වට තමයිලා ඊටත් වඩා කෙටි කාලයක්. Right? Half a second maybe. ඒක ඉක්මනට වෙනවා. Right? So in here, in the multi-step reaction, we can identify one step. It is difficult to happen. One step difficult to happen. It take a long time. It will decide the time taken to complete the overall reaction. The rate of the overall reaction directly decided by the slow step in the mechanism. The slowest step in the reaction mechanism, we call that one as the rate determining step. So in this one is the rate determining step. This one is a fast step. This one is the slow step. Okay. Usually when you consider a multi-step reaction, in that one we can identify one step. We can identify one step, right? It is difficult to happen. It take long time, more time. It will decide the overall rate. We should know the mechanism and we should know how these contribute to the overall rate. Mean in another way, we should know the rate determining step. And then about specific karamang. You should know the mechanism and also you should know the rate determining step. What is mean by that rate determining step? If you consider energy profile, in energy profile, according to that one, it is like this way. within 2 seconds. Okay, but after then, a long time. මම මේක මාරු කරන්න. 5 minutes, 2 seconds. 2 seconds වත් යන්නේ 5 minutes කියන්නේ මෙතන ටක් ගාලා යනවා ප්‍රොඩක්ට් එකට. It is like this. So in a multi-step reaction, slowest step, we call that one is the rate determining step. ඔයගොල්ලෝ මම මේ කියන දේ තේරෙනවද? මෙතන පොඩි සාපේක්ෂ කිරීලක් තියෙන්නේ. දැන් අපි කලින් අර reactions කරනකොට එක්කෙනෙක්ගේ concentration එක ගොඩාක් වැඩි කරපුවාම it is almost constant. මෙහෙම හිතුවේ ආන්නේ වගේ. දැන් මේ මුළු reaction එක ගත්තාම if you take the overall reaction, rate is decided by the slowest step. අනිත් steps ඉතාම වෙගෙන් යනවා. The slowest step we call that one as the rate determining step. Now all these things we consider for the multi-step. Single step එකට වැඩක් නෑ ඔය එකක්වත්. එකයිනේ තියෙන්නේ. තේරුණාද? But here this one is the rate determining step. Rate determining step mean in one way that step is difficult to happen. In another way, දැන් අපි ගාව දැනුම තියෙනවා in the multi-step reaction the step with the highest activation energy barrier is the rate determining step. තේරුණාද? මේ පියවර පැන ගන්න අමාරුයි. Again to the right reactants. මේ මැවිලා තමයි මේක overcome වෙන්නේ. ආන්නේ step එක තමයි අපි කියන්නේ මොකද්ද? Rate determining step. හරිද? ලියමු. Rate determining step. When consider a multi-step reaction, comma, in the reaction mechanism, some of the steps will complete rapidly. Some of the steps will complete rapidly. And some may take place very slowly. Red pen akan with a red pen. In a multi-step reaction, the slowest step in the mechanism within a bracket, slowest elementary step. Slowest elementary step close bracket is called the rate determining step. සාමාන්‍ය පැන ලියන්න දැන්. Rate determining step is the step having RDS is the step having highest activation energy barrier. In the mechanism. is the step having highest activation energy barrier in the mechanism. Leave a line and write this. Consider the following reaction mechanism. Consider the following reaction mechanism. A plus B, AB, AB plus B, AB2. A plus 2B, AB2. Here you write this one is the slow step. This one is the fast step. This one is the slow step, mean this one is the RDS, rate determining step. Harida. In front of this sun. Draw a simple energy profile. Make a profile in Taggal. Energy reaction coordinate. Energy reaction coordinate. මේ ගන්ධිපති දැන් මේ ඉන්ටර්මීඩියට් එක මීටත් පහලින් දාන්න එපා ඈ. يعني මෙහෙම අඳින්න එපා. reactance intermediate ඊට පහළට ගේන්න එපා. A plus 2B. Intermediate here AB. Right, product here AB2. AB2. Activation energy. Right. Now this step is the RDS. මේක තමයි RDS එක. Rate determining step. හරිද? දැන් මේ අහන්නකෝ. This one is the slow step. This one is a fast step. Overall rate. දැන් මට හිතන්න ඕන මෙයා ගැන. Overall rate. සාමාන්‍ය වෙලාවට අපි දන්නේ නෑනේ mechanism එක. We have this one. Rate of this overall reaction directly depend on the rate determining step. Directly depend on the rate determining step, slow step, or directly depend on the rate constant of the rate determining step. Rate constant low mean rate low, rate constant high mean rate high. Right? Slow reaction is this one. Rate of this one decide the overall rate or the rate constant of that one, right? Almost decide the rate of the reaction. Terunada? Liandago? Consider the magnetic area. Liana Kalin Taria Bandagumi. Now rate determining step is this one. Even for this one, I told you earlier, we can write a rate equation, rate law. For each of these steps, we can write the rate law. We learned that one earlier. But now this one is the rate determining step. Therefore, using the rate determining step, actually we can write the rate of the overall reaction. May rate determining step එක පාවිච්චි කරලා මට මේක ලියන්න පුළුවන්. Right? Rate determining step this one. So I can write this one R equal K, the rate, right, equal K, A concentration, B concentration. Why I wrote AB? Coefficient 1 here, coefficient 1 here. Rate determining step use karala. Using the rate determining step, you can write rate law or you can write rate equation for the overall reaction. මේ මම ලියලා තියෙන overall reaction එකට rate law එක. හරිද? But now here this one is a slow step, this one is a fast step. If this one is here, slow step is here, right? You have to learn something more than this. තා පොඩ්ඩක් උගන්නන්න තියෙනවා. දැනට කිව්වේ. අදහසක් විතරක් දැනට තියාගන්න. Right? Using the rate determining step. Now, if it is a elementary reaction, one step reaction, directly you can write the rate law. එකවරම ලියා ගන්න පුළුවන්. If it is a multi-step reaction, we have number of steps. Then which step will decide the overall rate? Rate determining step. Right? If you have the rate determining step, using the rate determining step, we can produce rate law or the rate equation for the overall reaction. හරිද? හිමීට යන්කෝ එතනට අපි බලන්න. ලියන්න මෙහෙම. Consider the following example. Consider the following example. Right? ලියන්න මේක. A into B. A into B. B into P. Net reaction A into P. Right? A into P. A into B in that one rate constant. You take that one as K1. You take this one as K2. K1, K2. Right? Then right. Assume that K2 higher than K1. ඕනනම් K1, K2 define කරගන්න පුතේ මෙතන. K1, K2 mean rate constants. K1, K2, they are rate constants. Rate constants. Rate constants high mean rates high. මෙතන K1 K2 කියන්නේ K1 mean rate constant of this step. K2 mean rate constant of this step. හරිද? දැන් මම මේව ලිව්වනේ. K ලියලා තියෙනවා. කිව්වේ කොහොමද? assume K2 is higher than K1. K2 higher than K1. මොකක්ද ඔකේ තේරුම? K2 higher than K1 mean which one is rate determining step? This one or this one? මෙයා වැඩි කියනවා. එහෙනම් මෙයා අඩුයි. මෙයා අඩුයි කියන්නේ මෙයාගේ රේට් එක අඩුයි. So rate determining step is this one. තේරුණා? ලියන්න. Assume that K2 higher than K1. Then first step proceeding slowly. Then first step proceeding slowly. And the second step proceeding rapidly. And the second step proceeding rapidly. The rate determining step is the rate determining step is the first step. Rate determining step is the first step, comma, which having lower rate constant, which having the lower rate constant. Next line. Hence the overall rate depend on the rate constant of the slowest step. Rate constant of the slowest step within a bracket rate determining step. Slowest step within a bracket rate determining step. හරිද? Next, right. Consider the following reaction. Consider the following reaction. Consider the following reaction. ආයත් ලියන්න මේක. දැන් ඕගොල්ලෝ නිකන් තේරෙන්නේ නැති එකම තැන කරගෙනවා වගේ. නෑ එහෙම නෑ. හරිද? එකපාර ඔක්කොම ටික කියලා දෙන්න බෑ පුතේ. එහෙනම් මේ පියවරින් පියවර මම කරුණ වැඩි කරනවා. එකපාර කිව්වොත් ඕගොල්ලෝ පොඩ අවුල් වෙනවා මෙතන. හරි? Mark this one slow. RDS. This one fast. Right? Overall එක ගන්න. A plus 2B, AB2. Then right. දැන් ඔයගොල්ලන්ට මෙකැනිසම් එකක්ම ලියන්න කිව්වොත් පුතේ kinetics වල with the rate law you have to write the right steps in the mechanism. Mechanism එකේ steps ටික ලියන්නත් ඕන. And also you have to mark the rate determining step. ඒ කරුණු දෙකම ඕන. නැත්තම් අපිට මේ mechanism එකෙන් වැඩක් නැහැ. organic නෙමෙයි ඈ. Right? Mechanism එක අපිට පාවිච්චි කරන්න පුළුවන්. You can use the mechanism to predict the rate law. To predict the rate law from the mechanism, we need the mechanism as well as which one is the slowest step or the rate determining step. ඔන්න ඔය කරුණු දෙකම ඕන. හරිද? mechanism එක ලියලා තියෙනවා RDS ලියලා නැහැ. වැඩක් නැහැ. You cannot predict. But here now slow step given they are using that one can explain the rate of this one. දැන් ඒ වැඩේ කරන්නයි යන්නේ මේ. ලියන්න. We can write the rate law. We can write the rate law for the overall reaction. Rate law for the overall reaction directly by using the rate determining step. By using the rate determining step. මේ වෙලාවේ පුතේ මෙතන මාක් කරන්න earlier one in that one K1 K2 K simple K rate constants K1 K2 K. Right. So using rate determining step, I can express the idea about the rate of the overall reaction. Lian, rate of the overall reaction, rate of overall reaction equal K1 A concentration, B concentration. This is a elementary step. එහෙනම් මෙතන තියෙන coefficients කෙලිම orders කරන්න පුළුවන්. In a K1 A concentration, B concentration. Now leave මොකේද? For the overall reaction, we can write the rate law using rate determining step. The multi-step reaction එක rate determining step එක use කරලා in a multi-step reaction using the rate determining step we can write the rate law for the overall reaction. හරිද? දැන් මම මෙන්න මෙහෙම වැඩක් කරනවා. Here I will change this one. I will take the slow step here, fast step here. ලියා ගන්න. Consider the following reaction mechanism. Consider the following reaction mechanism. අහගන්න. Again I want to take the same mechanism. පොඩක් අහගන්න වෙනවා. Same mechanism. But now we believe something like this way. Earlier this one is slow one, this one is fast one. ඉතා හොඳින් අහගන්න. This one slow one, this one is a fast one. Slow one, reactance, energy barrier, fast one, and to the product. Overcoming this energy barrier mean this one is nothing. Easily this one overcome and pass the product. Okay. So earlier this one is the rate determining step. Now what happened? If I change this one and this one, that means this one is a slow one, RDS. This one is the fast one. Okay. Then the reaction will be like this way. Though the initial reactants pass to the intermediate, intermediates have to wait there until overcoming the second step. Until overcoming the large energy barrier. This one has to wait here. Okay. So this one has to wait here because of that one. Small energy barrier. Again, that one possible to the reverse. Again to the forward. Again to the reverse. Therefore, we believe here, when the energy profile is like this way, initially the fast step, then the slow step, rate determining step. Then we believe this initial fast step, that one is in pre-equilibrium. It is in a pre-equilibrium. It is in an equilibrium. Reversible process. අයියේ මෙයා මෙතෙන්ට බලාගෙන ඉන්න ඕන. එයින මොකද වෙන්නේ? ආපහු යනවා. So we assume that one is a equilibrium process. Okay, then because of that one, now this one is a fast one, but now that one is a reversible process. Harida? Where that thing happen? Slower step. Before that one, slower step mean rate determining step. Before the rate determining step, if some other steps. Before the rate determining step, if some other steps, they are fast steps, but all they are in equilibriums. We say they are pre-equilibriums. They are in pre-equilibriums. තෙරුණාද? එහෙනම් අපි මෙකැනිසම් එකක් බලනකොට if the slow step here, above that one, if number of steps there, all they we can assume as reversible reactions. But after this one, if a step here, they are one way. Rapidly pass to the products. හරිද? Then it is like this way, fast one, slow one. When it is like this way, right here, reversible process, for that one, I can think about the equilibrium constant. On එයාට මං equilibrium constant එකක් දැම්මා, capital K. හරි? ඔය ටික තේරුණාද? Slow step, above that one is fast steps. All day possible to assume as reversible, pre-equilibriums. දැන් මට පුළුවන්. Again I can write the rate law for the overall reaction. Rate law for the overall reaction. Using what? Using rate determining step. ඕනම reaction එක rate determining step එකෙන් overall rate එකට equation එක ලියන්න පුළුවන්. හරි? එහෙනම් මම මෙතනට ලියනවා. Rate equal K2 AB concentration. All right, AB concentration, B concentration. Why I keep 1 1? Because coefficients 1 1. ඊට වැඩි තියෙන්නත් පුළුවන්. Now this thing all right. But for the overall reaction, you can leave that as the final rate equation. Because AB is the intermediate. Overall reaction when this one given as the overall reaction, how to write AB with that one? How to write the rate? AB කියන එක අපිට පේනවද? It is not possible to observe. It is in the mechanism. Therefore, secondly, what we do? We remove this one. You have to keep the last answer with the reactants A and B. AB වලින් තියන්න ඕන. දැන් මම මොකද කරේ? Using rate determining step, we wrote the rate equation on a ලිව්වා. But you cannot keep intermediates in that one. Rate equation එකේ intermediates තියන්න බෑ. For that one, earlier pre-equilibriums, we use that one. මේක use කරනවා. හරිද? Here you have the equilibrium constant. I told you that one. Take as the capital K. I can write the equilibrium constant K. K equal. Then the ලියමු අපි තාම equilibriums දන්නේ නැනේ. AB concentration divide by A concentration, B concentration. I diff coefficients here. We take those as the powers here. For example, if 2AB, here it is squared, like that. Hari? Enam mata puluang. AB, I want to remove that one. AB concentration mean equilibrium constant. A concentration, B concentration. This is the rate equation. This is in another way relationship. Now I substitute AB instead of that one. I substitute this one. Okay. Then I can write rate equal K2 AB instead of that one capital K, A concentration, B concentration. Okay, then this one. This one is a constant. This one also constant. Collect together. That is the simple K. Rate constant of the overall reaction. Terunada, instead of these two, rate equal K. A concentration, B concentration squared. Like that way you can reach to the right rate equation or the rate law for the overall reaction. Then make a වැරදිට තීරුම් ගන්න එපා පුතේ. A plus 2B එහෙනම් ඉතින් මේක දිහා බලලා ඉවත් අරකමනේ එන්නේ කියලා. It won't happen in all places. මේකට එහෙම ඩිරයිව් වුණාට හැමතැනට මේක එන්නේ නැහැ. හරිද? මෙතන තියෙන වැලියු එක නෙමෙයි ඔය ඇවිල්ලා තියෙන්නේ. This is a multi-step reaction. These coefficients not right directly give the orders. හරිද? පැහැදිලි? Right? This is how to derive that one. Right? ඔතෙන්ට එන්න කලින් ලියන්න තියෙනවා ඈ. අපි ලියලා තියෙන්නේ අන්තිමට මෙතෙන්ට එනකම් විතරයි. ලියා ගන්න මේ ටික. In the reaction mechanism, if fast steps are possible, in the reaction mechanism, if fast steps are possible, before the rate determining step. Before the rate determining step. It is assumed that those fast steps are in pre-equilibriums. Fast steps are in pre-equilibriums. Pre-equilibriums. Come on, because the intermediates produced by those fast steps have to wait intermediates produced by those fast steps have to wait until completing the rate determining step. Until completing the rate determining step. Hence we can derive the rate law. Hence we can derive the rate law for the overall reaction. For the overall reaction in such cases as given below. In such cases as given below. පුතේ ඔයගොල්ලෝ මේක කලින් ලියලා තියෙනවනේ. capital K මේ ඉදිරියෙන් කොහේ හරි ලියලා තියාගන්න. capital K mean the equilibrium constant. K2 mean the rate constant. Rate constant of the second step. Make a equilibrium constant capital K. දැන් මේ ටික derive කරන්න. හරි ඉස්සෙල්ලම ලියන්න. derive කරනකොට ආයෙ ලියන්න ඕනේ නෑනේ මේ ටික. ඕනද? ලියලානේ තියෙන්නේ. එහෙනම් ලියන්න from rate determining step. From RDS. RDS වලින් පළවෙනි එක ලියන්න. rate equal පුළුවන් තරම් ස්වාධීන වෙන්න මේකෙන් ලියන්න. ස්වාධීන වෙන්න කියන්නේ ඔයගොල්ලෝ හිතලා ලියන්න කියලා බෝඩ් එක බලාගෙන ලියන්න නැතුව. හරිද? RDS වලින් rate එක ලියන්න පුතේ. මේක එලිමන්ට් එකක්. එහෙනම් කොහොමද? rate equal K2 AB concentration B concentration. නේද? right? ඊළඟට ලියන්න මේකට පස්සේ from equilibrium law තාම දන්නේ from equilibrium law සමතුලිතතා නියමය කියලා මේක ලියන්න. K equal capital K equilibrium law capital K මේ බලන්න පුතේ. This concentration divided by product of these concentrations. Right? Coefficients තිබ්බනම් ඒගොල්ලෝ powers බවට පත් වෙනවා ඈ. I want to remove the intermediate. Intermediate එක මම මේකෙන් අයින් කරගන්නයි ඕන. ඉන්න එයා subject එක කරගන්න. AB concentration. right? AB concentration. Capital K A into B. Label that one as number 2. From 1 and 2. Combine karan. From 1 and 2. Rate equal K2 capital K. A concentration, B concentration, B concentration. මේ වෙන් කරලා ලියලා පුතේ ඊට පස්සේ එකතු කරන්න. Then rate K to K instead of that one K. A concentration, B concentration squared. Below this one, K equal K to K. Rate constant K for the overall reaction. Right? Lian. Consider the following overall reaction. Consider the following overall reaction. A plus B plus C. Right. A plus B plus C equal D. Oh, into D. A plus B plus C into D. Maybe confirm කරන් යන්නේ නැත්නම් මඩායි කියන්නේ. Lian, if the rate law for the above reaction is may overall reaction එක අදීලා තියෙන්නේ rate equal K A concentration, B concentration, C concentration. A, B, C. Bana predictions කියන්න ඔයගොල්ලෝ. මොනවද? You can say this may be. This is a elementary reaction. No. You can't say that one exactly. This can be. හරි මේ දැන් extract එක එන්නේ ඈ. එන හොඳට අහගන්න. තව ටිකක් තියෙනවා අපිට. නමුත් මෙතන තමයි තියෙන්නේ point එක. This one given in that one A component, B component, C component, and also according to the given one 1 1 1 1 1 1. ඉතින් අපිට හිතෙන්න පුළුවන් this can be. This is a definitely elementary reaction. No, you can't say like that way, but this can be an elementary reaction. If it is an elementary reaction, it is all right. පුළුවන්. හරිද? එහෙම නැත්තම් all these three components are there mean right? We have another prediction. What is that prediction? This can be a multi-step reaction. Can be a multi-step reaction. In that multi-step reaction, A, B, C from that one, some of the reactants involved in the rate determining step, and some other of the reactants should be in a pre-equilibrium before the rate determining step. Okay, say for example, when happen in this kind of one, a slow step happen, slow step. After the slow step, in a fast step, certain component, that one very rapidly complete, pass the completion. The time taken to complete that fast step is negligible there. Now we see if a mechanism in that one after the rate determining step, if some sort of component, another reaction happen here, fast reaction, effect of that one to the overall rate is negligible. Actually, such component in a in a step, in a fast step after the rate determining step, such component with respect to that one, actually it is zeroed. Mean concentration of that one change, no effect to that one, to the rate. We say that one is zeroed. Zeroed reaction. දැන් මේ බලන්නකෝ. A plus B into AB. AB plus B into AB plus C into D. This one is the rate determining step. That one is the rate determining step. This one is a fast one. Overall reaction is AB cancel, A plus B plus C into D. For the overall reaction, I can write the rate law using this one. So I can write rate equal K or K1, right? A concentration, B concentration. But in our overall reaction, C also there. C hitia method in our overall reaction. But for the rate equation, C is not there. C ආවේ නෑ. තේරුණාද? තේරුණාද කියපේක? Mean now, this one missing mean it is zeroed. Zeroed mean change in the concentration of that one, not affect the rate. Mean if a step, rate determining step, if a step after that one, mean a fast step, if certain reactant involved in a fast step after the rate determining step. Okay, that term will not be in this one. Or in another way, concentration of that component not affect to the rate of the reaction. Concentration of that component not affect mean with respect to that one it is zeroed. එහෙනම් අපි rate equation එකේ දැන් හිතන්න මෙතන පුතේ මන් දුන්නා නම් ඔයගලන්ට rate equation, rate equal K A concentration B concentration, C not given. දැන් ඔයගලන්ට මං කියනවා predict කරන්න reaction එක ගැන. මොනවද ඔයගොල්ලෝ කියන්නේ? A and B may be in the rate determining step or can be the step before the rate determining step. Pre-equilibrium එකක ඉන්න පුළුවන් එක්කෙනෙක්. But C definitely after the rate determining step. මෙතන C නැත්තම් if C is not there, only AB mean C not involved in the rate determining step or a fast step before the rate determining step. C in the bear, C cannot be. නේ මං කිව්වේ කොහොමද? මාරු වුණා. ආපහු. If it is like this way, A, B, C. ඔමිතමු. A, B, C. Right? A, B, C all in the rate equation mean A, B, C components. They can be the rate determining step. If not, they can be, some of those can be in a pre-equilibrium before the rate determining step. දැන් මම ඕකම දෙනවා rate equal K A B. Now you can say, right, this is definitely a multi-step reaction. පළවෙනි කාරණය. දැන් කලින් කිව්වේ කොහොමද පුතේ? This can be a elementary reaction වෙන්නත් පුළුවන්. If not, multi-step reaction. If this one is a multi-step reaction, A, B, C can be in the rate determining step, or some of the components can be in a pre-equilibrium before the rate determining step. Rate determining step එකට උඩින් තියෙන pre-equilibrium එක ඉන්නත් පුළුවන්. If I give it like this way, C missing mean with respect to that one is zero order. Mean that C should involve in a fast step after the rate determining step. After the rate determining step. Then you can see AB may be in the rate determining step or in a pre-equilibrium. ඔන්න සාරාංශය. තේරුණාද කීපෙක? ඒක දැන් අපි අර කලින් 0 order කියපු දේ 0 order කියලා කිව්වේ. දැන් ඔන්න ඉන්න තැන ඔයගොල්ලන්ට තේරෙන්න ඕන. තේරුණාද? ඊළඟට with respect to one component reaction is 0 order mean definitely reaction, overall reaction should be definitely a multi-step one. Elementary වෙන්න බෑනේ. තේරුණාද? ඊට ඔය එහෙට මෙහෙට කරකෝ අහනවා. තේරුණා? ලියා ගන්නකෝ එහෙනම්. දැන් මම ඒ ටික මෙතන හදලා දෙන්න යන්නේ ඈ. මෙතන අපි ඉන්නේ. මේ ටික ලියාගෙන යන්න ඈ. If the rate law for the above reaction is කියලා මේක ලිව්වා. Then asterisk mark. Asterisk mark. Above reaction may be an elementary reaction. May be an elementary reaction. May be an elementary reaction. ඊළඟ රූල් එක යන්නේ if not කියලා ආයත asterisk mark එකක් දාන්න. If not, another asterisk mark. Above reaction can be a multi-step reaction, can be a multi-step reaction, and in that multi-step reaction, A, B and C can be in the rate determining step, or some of the components or bracket එක දාන්න from ABC, some of the components from ABC, close bracket, can be in a pre-equilibrium step, before the rate determining step. Before the rate determining step. තව විනාඩි කඩක් ඈ. If the rate low, ilang rule liyanna rule kalla hari kamak. If the rate low is given as, if the rate low is given as rate equal K A concentration B concentration, then above reaction cannot be, then above reaction cannot be an elementary reaction, an elementary reaction. It should be a multi-step reaction. It should be a multi-step reaction. Reactants A and B can be in rate determining step or in a pre-equilibrium step, can be in the rate determining step or in a pre-equilibrium state, pre-equilibrium step. A and B can be in the rate determining step or in a pre-equilibrium step. But C must be in a fast step. C must be in a fast step after the rate determining step. After the rate determining step. හරිද? itu ටික ඊළඟ දවසේ කරමු. පේපර් ක්ලාස් එකේ ඉන්න අය කැම කාලා ඉන්න. right. ඊළඟ දවසේ 6ක විතර වැඩක් තියෙනවා. 6කටත් වැඩියයි. ඒකෙලෙදි මීට වැඩිය වේගෙන් උගන්නන්න බෑ පුතේ. දැන් මේක මේ පේනවනේ බොහොම පරිස්සමට එක එකතු කරන්න. ඕගලන්ටම තේරෙනවා දැන් මේක මට ආටිෆිෂියලි කියන්න පුළුවන්. මෙහෙමනම් මෙහෙම ගන්න කියලා. ඒතර තේරෙන්නේ නැහැනේ මොකද්ද වෙන්නේ කියලා. තේරුණාද? මෙහෙමනම් මෙහෙම ප්‍රොඩියුස් කරන්න කියලා දෙන්න පුළුවන්. මෙහෙම නැතුව දැන් මේ ඕගලන්ටම තේරෙන පිළිවෙලට අරන් ගියේ. හරි ඒක ටිකක් අමාරු වැඩක්. හරි. බ්‍රේක් එක අරන් ඉන්න ඔයගොල්ලෝ මේ කෑම කාලා මං ටිකක් කලින් දෙන්නම් පේපර් එක. 1:10යිනේ. 2:00 කාලේ විතරෙදි දෙන්න. 2 වෙදි දෙන්නත් පුළුවන් පේපර් එක. ඒ පොඩි විවේකයක් ඕනේ කන්න. හරි. 2:00 කාලෙ වෙද්දි දෙන්න. එතකොට ඊළඟ දවසේ පුතේ මම මේ පාඩම ඉවර කරලා ඉලෙක්ට්‍රෝකෙමිස්ට්‍රි පටන් ගන්නවා ඈ. වෙන ඉලෙක්ට්‍රෝකෙමිස්ට්‍රි ලියා ගන්නත් සටහනක් ගේන්න ඈ. එකම පොතේ ලියනම් කමන්නේ.